thanks for joining us. This is actually your second engagement today, right?
Yep.
Well, I was trying to explain the event you were speaking at earlier, but I think I'll let you do a better job of it.
Sure. It was a session for sensor-based ore sorting, technology we'll talk a bit about today here.
Yeah.
Very popular this year. So it was standing room only in the back. It was just packed.
Yeah, there's a lot of interest in it,
Yeah.
and I've walked on the show a bit and talked, and there's lots of murmurs about it.
Yeah.
And what's your? We'll start off with your background. Kind of where you're from, and what you specialize in the industry.
Sure. So I've got going on 20 years of experience in mining. Went through operations in gold and copper, lead, zinc. The last 5-6 years or so, I've been in engineering, and recently gotten into, well, I guess 3 years ago, into ore sorting. Studies, construction, that sort of thing.
Yeah. So when we talk about sensor-based, I butcher it every time. You've been trying to teach me, but when we talk about sensor-based ore processing, what is? I mean, just in the simplistic terms, what is it? What are we talking about?
So you're using a sensor and measuring a quality of the rock. So it could be frequency of light, color. Could be X-ray transmission or X-ray fluorescence, electromagnetic, infrared, laser. And you're looking at that characteristic of the rock and comparing it to a database of other rocks and for that deposit. And you're looking and saying, is this ore or is this waste? And can I train the computer to tell the difference instantly in order to divert that rock into ore or into waste? And it not just particle sorting like we explained here, but it could also be bulk sorting, where you can diverting hundreds of rocks at a time. Shovel sorting, where each scoop is analyzed. There's a lot of different potential uses for it.
So to go into that a little bit more, so at these different points, why would you? Some of the questions are going to be very simplistic questions from me, but why would, at these different points, why would you put it there as opposed to another area? Is it depending on the mining operation, the type of mining?
Yeah, it'll depend on cost, tonnage, cost to process. So if you've got a very, very large open pit deposit, you're going to want to consider scoop sensors. You're going to want to consider bulk diversion systems. You may also consider particle sorting, but you don't want to jump straight to particle sorting because it's rather expensive per ton compared to some of the very bulk cheap methods.
Right. So could you explain particle sorting a little bit more?
So particle sorting is when the ore starts on a traditional conveyor, but is then spread out over a much wider conveyor so that each particle is exposed to the detector above it. All rocks are scanned simultaneously, and then as they fall off the end, the computer has by that time decided that, yeah, this is worth keeping, so it'll fall into the ore bin. Or if it's worth rejecting, could be a mechanical diverter or an air jet will bump it into the waste bin.
How accurate is this?
Your accuracy depends on particle size and your algorithm and your sensor, but 85 to 95% accuracy is pretty common. Could be higher, but it depends on the deposit.
I was doing a little bit of my own research on it, and it said some of the reasons that this is coming in now is because it's harder to find high grades in material now. So is it a demand is why this is becoming part of the industry now? Yeah,
especially in the gold industry. Excuse me.
Oh, no worries.
The cutoff grade and the deposits available have been steadily decreasing in grade, and profits have suffered. To an extent, that's made up for by the rising metal prices. But if you can take a 2 gram per ton gold operation and bump that up to 4 or 5 grams per ton, your profitability just, the whole equation changes.
Yeah. And is it how much cost, so your higher productivity, assuming that you've actually got the material there, recover. But how much is the cost? Cost increase, I should say, percentage-wise.
So percentage-wise, we've never actually done it that way, but approximately 1 to 3% probably.
Okay.
Compared to traditional processing, it could be 5% up to, yeah. But it's very cheap and simple. You've got a sensor, you've got some electrical costs, you've got the conveyor. But compared to a grinding circuit or a flotation circuit, the costs are fairly trivial.
And where's the future going in this? Like, is this something that's here and now, or like, I mean, where is this going to end up?
So
5 years from now?
Right now, the top size limit is about 4 inches for a machine. We'd like to see that increased as far as possible. The higher the limit, the less crushing is required before sorting. Every time you crush, there's a certain amount of material that ends up minus ½ inch, which is our practical undersize limit. You want to reduce the amount that's undersized so that you can sort a higher proportion of your ore. Other improvements, sensor accuracy, sensor selectivity, and just overall equipment capacity. For particle sorting, 100 to 200 is a fairly big machine. We'd really like to see 300 to 500 ton per hour machines.
Right.
But they're just not here yet because of the scale that would be needed.
There's something I was wondering too. Like when you take let's say a 24-inch conveyor and that sensor is on that conveyor. Now, does it need different equipment, or does the software and the sensors work within basically any type of equipment where it's applicable, or does equipment need to be customized, or is the program customized to the equipment?
Everything is pretty much customized. So if you're starting with a standard 24-inch conveyor and you put a sensor above it, you won't be able to do particle sorting, but you could do bulk sorting. So the sensor would tell the computer, hey, look, the last 30 seconds we've had really good ore. Send this straight to the mill. And then a minute later, it'll say, okay, the ore that's been coming by lately has been very poor quality. Let's start diverting this to the waste piles.
So, who are the main players?
You've got Steinert, Tomra, Redwave, Comex, Rados, and there's a few others too. And that's your particle sorting. And then you've got MindSense doing the shovel sorting. And you've got a number of other bulk sorting companies available. I'm trying to think of the name of it. I saw the guy at the conference here.
You can always tell us it later. We'll plug it.
We'll edit it in. That'll be fine. Great technology.
It's amazing what you can do. And these are these.
Oh, Scantech. There we go.
There
Scantech.
we go. Actually, we'll try to put those links into the descriptions as well. So
that would be fantastic. Yeah.
And so they're developing the technology and manufacturing, distributing it.
Exactly. Yes.
Yeah.
So we're an engineering company. We'll look at a particular deposit for a client, and then we'll look at all the technologies available and say, well, these ones have the best chance of working for this deposit. Right. Let's check these ones first.
And so, and that was actually my next question. So where does Sacre Davey come into this process? And you're actually making the recommendations for this technology depending on their needs. So does that mean that you are specializing in this as opposed to another engineering firm that's not quite up to date on it, or how does that?
Well, we're definitely leaders in ore sorting, but we also do flotation and grinding and leaching and all those other things because we have specialists in all those areas.
Right.
But the last few years we've got the most traction with ore sorting. We've had over 30 projects in ore sorting, including some that were constructed and built, and we're building a couple more this summer. So it's definitely been the most popular thing we've seen in the last 3 years.
Right. Because of limited ability to, or depleted
just the economic impact that ore sorting does. It's, when I tweak a mill circuit, I can squeeze an extra 3%, 5% from it. And that would be a huge accomplishment. Or I can trim a few million out of the budget. When you put in ore sorting, your production might go up 50% or 60%.
Really?
Yeah. So it's just a complete game changer, and that gets mining companies' attention.
Right.
A lot of times they'll be very resistant to any sort of change or any sort of new technology, because that's the nature of the industry, and that's fine. But when you get a business case like this, and it's so compelling, it's much harder for them to resist that opportunity.
Yeah. And are there mines? I know you said there's sort of the size or a limit on how big the sensors are.
Or each individual particle sorting machine, yeah, it's
Right.
limited to maybe a couple 100 tons per hour.
Right. So are there mines now though that are in that size range that have the full system in place? Are you seeing it now?
Yes, and I've seen packs of 5 to 10 machines. So they come grouped together, so they're able to do 1,000 tons per hour or something like that.
I mean, obviously, to me, it would seem that you've got this technology, and then you've got the OEMs that are manufacturing this equipment and bringing it to market. There must be a huge demand for partnerships in this kind of to get this technology to a sort of a mainstream in the mining industry.
Yep, exactly. So I know MineSense is working with a few people in partnership. Tomra and Autotech have joined forces. Tomra provides the equipment and the experience. Autotech provides the sales power, and they've worked together. I think we're going to see a lot more of that, especially as this becomes more and more mainstream.
Yeah.
And based on reactions at this conference, I think it already is now considered a mainstream technology.
Yeah. But it hasn't gone through full implementation yet. It hasn't fully integrated into the systems.
Ooh, it has at quite a few places.
Right.
Maybe 100.
Yeah.
It's tough to get accurate numbers, as
Right.
a lot of places will not release their data. We were very happy to have 4 mines release their operations data to us so that we could present it at this conference. But that's sort of a new trend.
Yeah.
So it's tough to tell how proven the technology is, but it's definitely very commercialized.
Right. Yeah. And actually, I'll wrap up with this question: is where, and I think you've answered it in some ways, but ultimately, where is it going to go? Is it going to become standard? You set up a mine, you have the sensor-based ore processing in place, like just standard.
It'll probably end up being one of the go-to technologies. So not every mine has all the same pieces of equipment, but things like SAG mills and crushing and grinding and flotation and leaching are pretty much standardized. So if you have a sulfide deposit, you do this and this and this. Ore sorting would be one of those pieces. And I think it will become more and more of just a step, a standard step that people take when they're evaluating their deposits.
Yeah, yeah. That's I'm going to add one more question for my own curiosity. When you talked about sorting, and before it goes into maybe it gets sorted before it goes into a crushing system, or would it not get sorted?
It could.
Yeah.
So some of the technologies before crushing. Usually if it's particle sorting, it'll be right after the first crusher. So your gyratory or your jaw, then your sorter.
So is that going to lead then to less wear so a more efficient operation, less wear, less maintenance on the machines, because you're not handling basically material that's doesn't need to be processed?
In theory, yes. In practice, it won't, because if I'm able to take 1,000 tons, reject 500 of those because they're worthless and we would have lost money processing. So those are gone. Now you've got a mill designed to be able to handle that 1,000, but you've only got 500 left. Yeah, you'd save on wear and tear and costs, and that's all great. But the first thing that mine is going to do is find another 500 tons to replace that.
Right.
So that's where you're able to, in that case, if you're able to replace that with an equal grade, you could almost double your mill production, metal production.
Now, is that in theory or in practice? Have you seen that?
We have seen
result?
that. Yeah. We've seen 90%, 85% recovery in 10%, 15% of the rock, and that mine is able to, if they can get it from their pit, they can produce double their metal.
Yeah, that's incredible.
And that was a tungsten mine.
Yeah.
Yeah.
Oh. Yeah, it's a lot of information. I mean, in speaking with you, I first learned about the technology, so it's so new to me. So it's kind of when I'm, some of the other topics we cover, you can have some basic idea in it, but this technology is something that you really do need an expert. So.
And it's a very big topic.
Yeah.
At the CMP in Ottawa, we did a whole day session, just explaining all the different steps and all the different tests and all the different flow sheets and applications.
Yeah.
And it's an 8-hour topic.
Is there some sort of literature or a place that you would send someone who's just trying to learn it, or is it a little spread out at the moment?
It is a little spread out. There's a lot of papers, but there's not a beginner's textbook.
Yeah.
An idiot's guide to ore sorting.
Damn it.
There's some advanced textbooks, but it's tough to jump straight into that.
Yeah. Yeah. Well, if you think of any,
I will let you know.
Please let us know. We'll put those in
Absolutely.
the descriptions, because there is going to be a lot of people that are interested that they'll be similar to me and that never really heard of it before, or have heard of it but don't have a good understanding. And I guess if nothing else, they can get in touch with you.
Oh, of course.
Yes.
I'm always around. They can just give me a call.
Yeah. Okay, Brent. Thank you very much for joining us for the podcast.
Well, thank you for having me.
Yeah. And I will catch up with you later.
Sounds good.
Okay. Thank you.